Right, it's time to look at the second piece of the project. Now, what I have in front of me is actually the document that you'll have uploaded to you that has all the pieces of the, part two. Part one was when we kind of just ran through the scenario of creating demand from from data, and your responses were great. There's some things that you might want to fix on those, and I've checked with a few of you. I'll also send a key so you can check against it. But your efforts were definitely not in vain, and I thought you did very nicely on the whole. Here is the blank sheet again. What I have for you is I took all our data from our class polls. We did a little survey of what your willingness to pay for a ray gun designed relays t-shirt. And so now here's just the front of this. Our t-shirt looked a little bit different, but you can just imagine we have this amazing relays t-shirt with some clever phrase that goes with it. Properly designed to look like a ray gun shirt, and to be a proud Iowan, you probably should have at least one ray gun shirt in your repertoire. Now, I have two files. This one's also part of that file I've uploaded. The Drake Release Project Part 2, and then there's this demand for T-shirt Fall 2016 data that just relates to you guys. Let me tell you about where this came from. Now, if you remember, I asked you guys what you'd be willing to pay for this T-shirt, and so how this unfolded is that I said, all right, here's the t-shirt, here's the basic idea. There were a few of you that said you'd be willing to pay a larger amount. So one at $37.50, three of you at $35, six, and so on. And so as we go along, the lower the price, everybody, by the time we got to the end, all students, I used your data and a little bit more from the last semester, so I wanted a nice even number of 70 students. Actually, only have 52 this particular semester, but I pulled in some data from last semester, thought that might be helpful. So now, by the time we get to $5, everybody wanted a shirt. So that was the one price that all would be willing to pay. But as you raise the price, fewer people are willing to buy it. So what I did then is next to it, if you look up in my little calculation bar, percentage is just to take D4, which is the cell here with 70 in it, and divide it by D4, which would be a 1, but as a percentage, of which I've converted it to, that's 100%. Now I put a dollar sign in there, which means as I dragged out this formula with the black cross, and I dragged it down, every one of these got divided by D4, D5 by D4, D6 by D4, and there's a percentage. So that gives you a percentage. Now the reason that's important is that based on some historical data, there was a really, really gangbuster year, I think it was 2013, where the relays attendance was about 41,000 people. Then every year after that, it's dropped to numbers less than 25,000, down to 20-ish, 22, and so on. So what I've done is said, hey, you know what? There's about 25,000 people there that are going to show up to relays. We can be pretty reasonable. That's a reasonable expectation. Weather has a lot to do with it. And that's total, by the way. That's for all, whatever, 3-4 days there are of Drake relays. So we're saying our market is 25,000 people, friends and family, and those students on campus and things like that. Not all of us go to relays, even if we are on campus. So I think that's a safe estimate. So if we say that your response, that $5 is a price you'll all pay for, we're going to take that and say, well, I think our population of 25,000 of people who attend, I think they'd be willing to pay $5 for a shirt. Then as we go along, I just took your percentage in our class of people who are willing to pay. I used it against the 25,000 people in attendance at the relays. And what we created is how many people at relays would be willing to buy this shirt. And so if you go down the list here, it's just our class percentage multiplied by the number of people that attend relays. And a conservative estimate, by the way. I used a conservative estimate of how many people attend because, as you know, things happen. And so there is our baseline data. Now, remember how demand curve works? We need an axis, a y-axis that's how many people. There's like a unit and there's a price, and it's all kind of goofy how this works. But we're going to convert this. Units is your x-axis, and it's a great way to tackle this problem. So what I want to do is capture this column here of price, and that's going to be our y-axis. Crazy that it's on the left-hand side, I know. And then the number of units, that means how many t-shirts we sell, is going to be right here. I know it's huge, 25,000, but that's going to be our x-axis. So in Excel, what you're going to want to do with this data that I hand you, and I'm preparing you to say you're going to need to do this calculation. I'm going to give you the document you see before you, but your need is to take these values and either cleverly just find a way to make a graph where the dollars is your y-axis and the total market is your x-axis. Or I think a nice way to do is cut and paste. If you guys go into edit, you've got a copy or a cut option. It's whatever you want to do. If you go copy and you take and paste it over here, then if you take the total market as your y-axis and you do copy and paste right here, then what you've done is you take that. Now, the funny thing is those little columns, you see weird numbers pop up. So we've had this happen in the past. If you hit undo, the way you want to paste, well, let's back up. Oops, sorry, undo. Here we go. The paste you want to use is special. Go to the top of that right-hand corner there. See where I've kind of highlighted that box. One of the things you want to do is do paste special because it is a special paste. You only want to paste the values rather than the formulas, because the formulas draw on like locations of cells, and that's not good at all. But if I use the values only, hey, things work out pretty well. So I get this nice little graph here. Now don't worry about these borders and how that all works out. Borders are actually pretty easy to work with. If you just highlight this and go, put all borders in there, voila, all is well. And so I'm going to take that and copy that and paste it. Okay, so I'm going to make a little graph out of this. That's the first part. We're going to call this video part 1. I want you to be able to copy and paste those values where x is on the left and y is on the right. And I want to do insert a graph. So I'm going to go in here. Remember how we do this? You find a scatter plot, XY scatter. I don't know how you're going to find it in your Excel, but everyone's a little bit different, it seems. This ends up being my demand curve where I have dollars on the left, and oh dang it printed it the wrong way. So now I made that little error on behalf of you guys, just to get you the idea that whenever you get done with your demand curve, make sure dollars is the y-axis and x units is your x-axis. So the graph that I just came up with, man, that was a bummer. We actually need to get rid of it, so I'm going to swap this around. As long as you, so I'm going to do another copy and paste. These columns are flip-flopped. I need to put my dollars on the right because the way the XY, if you go into insert and we do XY scatter, it always assumes the left is the X and the Y is the right. And so be careful. So I'm going to take this thing right here. I'm going to do my edit and I'm going to do cut again. And I'm going to do paste on the right-hand side of this. And I'm going to try my graph from here. And don't worry about the column, but the way it's highlighted. Hit XY scatter on here. Got it. And there it is. Now it's a demand curve. It's got that downward slope that we want. Dollars is on the y-axis. Units is on the x-axis. Perfect. Once you have that, then what we need from here is to go in here and do control click, command click, right click on a PC, whatever it takes to get an add a trend line. Once you click on a point, then we can use the various types of, we're going to do multiple types of regression on this and get all the equations. Okay, so if I choose linear, for instance, and hit enter, if I can scroll down here, I kind of don't know why my screen is not showing all this. Maybe I can get this to work. There we go. Linear, and then go down here and say display the equation in the chart. If I go back, if I close this, I should be able to see there it is. There's my equation. That's my linear equation. That is step 1, is getting an equation that goes with it. Now, if you look at our project, here it is. This is our, by the way, there's a little bit of a typo here, self and parent. There is no self and parent on your document. It should just say one person self or something like that. The 25,000 in total market is a little bit different. Basically, you have a grid here that matches what I have in that Excel document. Sorry for I didn't fix that early enough. But down below we have a place for you to put your equation, like our linear equation that I just got. I can put it in here. Now, if you go back to Excel, take a look at it. It's negative 0.0011x plus 36.7 plus 30, and I put that in for my linear. How well did it fit? That's an evaluation, your judgment call. Don't look for some answer that you think I want. Does it seem to fit okay? Is it off? One of the things we want to think about is how well does it fit not only this trend, but as time goes on, think about this. This is about number of units sold, or I'm sorry, that are the total market of sold t-shirts and based on the price. One of the things we want to keep in mind is that I don't think we're ever going to give away a shirt. It's not going to be zero. And this linear equation actually goes zero and goes to negative. I don't know. There's just things to think about, but it's not bad. So you get to make your evaluation. Then we're going to do a quadratic. And if you haven't done this before, you do the same thing we just did. You click on one of those points, you go add a trend line, but instead of choosing a linear, you do polynomial of order 2, which is quadratic, and you go down and say, hey, show me the equation. So I have to scroll up here, display equation. And then if you actually look at this, there it is, there's my equation. Now this is a goofy way that it writes it. See that thing that says 3e to the negative 0.08x squared? That's actually pretty close to 0. It means it's negative 0.0000. You have to move the decimal to the left 8 places. So negative 3.0, move the decimal 8 places, you get negative 0.7 zeros and a 3, and then x squared. Okay, so if you don't know your scientific notation, it's been a while. That's what that's saying. So that actually means negative 0.7 zeros, 3, and then x squared. It means move the decimal 8 places to the left in the situation where it's 3.0. All right, so that's your quadratic. You can write it in there, but you got to put the decimal in the right place. Is that a better fit? You want to look at it. Does that look good? Does it seem... I don't know. You can make that judgment call. There's 2 others on there. I want you to go about finding those regression equations, fill it in, and then what you'll do is answer the questions on here. There's exponential, it's one of those, and other. You can pick another one if you like. Actually, you do need to find another one, just of your choice. You can do cubic. You can do one of the other choices on there, but play around. You can do quartic. That means 4th degree, or the notation is, here, I'll look at this when I do a regression. You can choose any of these. Oh, excuse me. Make sure you get a point there. Boom. Add a trend line. You can choose polynomial of various orders. You can do a power function. Logarithmic is fine. But if you choose one, tell me if you like it or not. Write the equation of it, and then we'll go from there. Okay, so I'll give you some flexibility to choose another. All right, now it says on here, estimate the cost you incur from this. I'm going to make another video that gets you to. So basically what I've done is given you a situation where you can fill in this table, which by the way I'll modify, from the data you gathered. That's basically what 2 is asking you. Okay, you're doing that by doing the spreadsheet, what we've just walked through. B is you writing up a marketing strategy completely devoid necessarily of mathematics, but it's you saying how you're going to go about getting a good, increasing your sales number, getting that 25,000 people, making sure the word gets out. Linear, quadratic, how well did it fit? I want your opinion. I want you to look at the data. I don't want you giving me answers that you think I want. I want you to evaluate how well it fits. Okay, fill up that as much as you like. And then this piece right here, 3 and beyond, I'm going to make a part 2 video for this so that you can tackle that in another breath. All right, good work, guys.